Rahman. I'm a lecturer at a public university in Kenya. I deliver lectures in computing and informatics. In our last lesson, we discussed a recursive function, and basically we had seen and demonstrated that a recursive function calls itself. And on it, we had one challenge that a recursive function, if not well implemented, it calls up an infinite loop. So today, we are going to address that particular challenge by using up a recursive function to find out a factorial of a number. So in this particular journey, we are going to define what is a factorial and how is the syntax of a recursive function can be used without causing an infinite loop. And then finally, we're going to implement. So to start up that particular journey, we are going to define what is a recursive function. So let's start the definition of a recursive function. So basically, a recursive function, it is a product of, it is actually a product of positive numbers or positive integers less than or equal to 1. So they are less than or equal to n, and basically what we are saying, these are positive integer, they have to have a product or they have to be multiplied, and they are actually denoted by n with an exclamation mark, which it is read as n factorial. So this particular one, and the formula of of n factorial, it is actually n itself multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3, and goes on. So for example, if I want to say what is the value of 4 factorial, so it will be n, which is 4 times 4 minus 1 times 4 minus 2 times 4 minus 3, and finally this will give me, because it is less than or equal to n, so we'll have the last one less than or equal to n, because now if you do that, and it cannot move on more. So my 4 factorial basically will be 4 times 3 times 2 times 1, which will give me 24. So this is basically what is a factorial. So with that, let's see how can we actually implement recursion without having an infinite loop. So with that particular one, we had seen last time that actually we go to an infinite loop. So with this, we have to put up a condition, and that particular condition, we are going to use some of the statement which we are going to discuss them into detail into our next lesson, an if statement. So let's take, for example, we want to have an int factorial function, which it is a type 4. It takes up a return data type and also takes up one parameter list or one argument. So with that particular one, basically this will be our function, and this particular function we are putting up a condition here. So if we are saying n, this particular n is less than, it is greater than or equals to 1, because basically in factorial, what we are trying to say that it is all the positive numbers and positive or integers, and this positive integer should be less or equals to n, So we're using up this particular one, that n should be greater than 1 as our condition, and here basically what are we going to do? We are going to return, because we have to have a return data type. We are returning what? We are returning n. We are returning up this particular formula, n times, by calling up a recursive factorial, and that particular one n minus 1. So actually we are returning up this particular formula, or else what are you going to do? We are going to return the value of 1. So basically that is how the syntax of a recursion will look like. So finally, let's see how we are going to implement that. So our implementation, basically, we are going to find up a factorial of a number. So basically, we are going to take up a factorial. Let's say we enter 4. So a factorial of 4, basically, we had seen here, it is actually 24. So let's go now to dev C++ and see how we can actually implement the same using up the factorial. So here basically we are going to have our function definition, our function declaration. So we have got int factorial, and our factorial, it is type 4. It has to take up an argument. It has also to return up a data type. So here we'll have our int n, and then here at the bottom we are supposed to define, so it will be int factorial, and supposed to take int n, and then should have opening and closing curly bracket, and inside the body we are putting up our logic here in the body. So here we are saying if n, so this is if n it is actually greater or equals to 1, then do what? Then we are telling you to do what? We are telling you return what we are talking about, our n multiplied by, now we are calling up the factorial, that is now here it is where we are calling up our recursive function, and we are passing on n minus 1, we are passing on the formula. So this is how it is done. So let's finish up our if statement using up the else. So here we are saying else what? Else return 1. So here we are returning up 1. So here you have got basically the syntax and the logic of the factorial. Now let's call it on main. So if you want to call it up on main here, we have to declare some variables. So here we are telling up int num, int result. So we're declaring up 2 variables. Now we are telling up the user printf that they should enter a number, or should be into quotations. So we are telling them to enter an integer to find the factorial. So somebody has to enter an integer to find up a factorial, and then we're using up the scanf to capture that particular integer. So here we are having our percentage d as our format specifier, and then we are capturing the address of num. So we're capturing the address of num. After capturing the address of num, now we want to display the factorial, and in our syntax of type 4, we have to have a variable passed onto it. So we are saying our result should be equal to basically what? The factorial. Now we are calling up the recursive factorial, and what are we passing on here? We are passing on our num after being taken up from a keyboard. And then finally, we want to print it. So basically here, what are we saying? We are saying printf. We are saying here to printf what? Here we are saying printf. What are we printing? Basically the factorial. The factorial of, so here you are giving up your number, so we'll have a %d equals to the factorial which has been calculated. So we have got our %d, and basically we are passing on our num and our results. So basically this is how you can actually implement and see what happens without any infinite loop. So when we actually run this particular program, here we have not terminated this particular statement, so we have to terminate it. So let's run it now again and see what happens. So when we run this particular program, they're asking us to enter a number for a factorial. So I'm going to enter our number 4. So if you enter 4, we can see the factorial of 4, it is 24. So thank you for listening, and however, don't forget to subscribe in our next lesson. And basically in our next lesson, we are going also to talk about variables, the variable in a function. Thank you very much.